This week we'll be doing the last of our hand calculations and we'll be working with substitution problems. And so we're going to move on to our computer-based case studies after this section. But we want to learn about the concept of substitution because that's a lot of the principles and the foundation for what we're going to do. And so we need to have a good understanding of substitution type problems. And when we talk about substitution, let's talk about some different terms. We need to talk about substituting and supplementation before we get too far into this. When we talk about substitution, that's where we're actually going to replace forage with something else. And so if we take a look at this, notice that we are keeping intake about the same, but we are replacing a certain amount of forage with something else, like a grain or some sort of a supplement. That is what we call substituting. We are substituting something else in for the forage. But we can also supplement our animals. And there's two types of supplementation. I'm seeing that my little screenshot here is this graph is lacking a little bit, so let's get this cleared up. So we have substitution right here. That's where we replace some forage with something else, but we keep intake the same. Then we can supplement an animal. I'm going to erase that for right now. And we can supplement an animal, and when we supplement, it means that we are giving them an additive feed, and you notice that we are increasing this total intake. They're actually eating more than if it was forage alone. Now there's two types of supplementations. There's certain feeds that we can supplement that will actually, you notice, suppress forage intake, and there's some that will increase the forage intake right here and right here. The negative, and it's not always bad, it's just how it works, this is what we call a negative associative effect. The one where it's a negative effect because it's suppressing forage intake. The flip side of that is the type of supplementation that increases forage intake is called a positive associative effect. So you will need to make note that a negative associative effect is when we supplement an animal and the supplementation causes a decrease in forage intake even though total intake increases. A positive associative effect is when we supplement an animal and we use a small amount of, the classic example is a small amount of high protein supplement that causes beef cows to eat more forage. So a positive effect actually promotes the microbes to do their job in the rumen of a cow and increases total forage intake as well as total intake overall. So we have three things we're working with here. Substitution is the first one, which is simply replacing forage with something else. That's the type of problems we're going to be working with today. Then we have supplementation, which is different from substitution. Supplementing increases total intake, but we can have either a negative associative effect that decreases forage intake, or the third thing is a positive associative effect that increases forage intake. So kind of work through some of that. We have times that we actually want a negative associative effect. There's times we want a positive associative effect. We'll get a little bit more into supplementation when we get into the case studies. So when we talk about substitution problems, we've got to be able to calculate the pounds of a nutrient in a given amount of feedstuff. This is something we've been doing for several weeks now. For example, if I asked you that we have 50 pounds of corn, okay, pounds of corn, dry matter, and corn is 10% crude protein on a dry matter basis, how many pounds of crude protein do we have in that corn? That's simply taking the amount times the nutrient concentration. Whoops. I just wrote that wrong. The nutrient concentration on a decimal form. And so what we find out is that 50 times 0.1 equals 5 pounds of crude protein. That's the level of math that we do in a substitution. And so we've done a lot of the math already. The key to substitution problems is keeping yourself organized and staying on task. And so we've done this several times, that feedstuff amount times a nutrient. And substitution is commonly used in herbivores. And what's nice about substitution problems is we can do multiple nutrients. So like in our example that we're going to work through today, we're going to balance energy, protein, calcium, and phosphorus for a group of sheep. And so we're able to handle multiple feeds, multiple ingredients and nutrients in a stair-step type fashion. And so one thing that you will need to write down, so take notes right now if you've not taken notes on anything else, or make sure you print the transcript for these slides. Step 1 is you got to know the requirements of the animal. Almost always I will either give you a description of the animal that you have to look it up in a certain table, or I will give you the requirements. You need to get the nutrient composition of the feeds. And what we're going to wind up doing is putting these two into a common table that we can always refer to. And so these are things that are going to be given to you as part of the problem. The substitution where you're going to start doing the work is going to be step 3, where we need to determine the nutrient contribution of the major feed, which I'll explain. Then we're going to see if the animal's needs are being met. And for substitution problems, they're mostly done with herbivores. The major feed is the forage. So this is where we need to know our classes of feeds. We've got to know which one's the roughage or the forage. We've got to know which one's the energy feed, the protein feed, the calcium source. We've got to be able to tell which one is which. And so then we're going to see if the needs are being met. If yes, then we can actually convert to as-fed and jump straight to the last step. If no, we've got to do a few other things. We're going to determine what I call the net gain, which is the amount of nutrient gain for each unit of supplement substituted. We're going to take that deficient amount and we're going to fix the deficiency. You remember a couple weeks ago when we had a few math problems that are actually on the midterm that we had to find out an amount of feed to correct a problem? We're going to be doing that math again today. We need to reformulate the ration and check to see that we fix the one nutrient and see if there's any other problems, and repeat if needed and correct with another substitution. And so, and then the last step is correcting it for dry matter. That means converting it to an as-fed basis. So essentially, what we're going to be doing for these problems is what I think of as a stepwise approach. We're going to take a diet and we're going to check that for most part it's energy needs. Are energy needs met? If yes, then we're going to check the next one and see if the protein needs are met. If yes, then we're going to check calcium, then phosphorus. So it's a stair step. And if there is a deficiency, at each step of the way we're going to add an energy feed. Okay? If we need it, then we're going to add a protein feed. Some sort of a protein source. And then if we need it, we're going to add a calcium source, etc., all the way up through here. So we're going to start with forage only, because which would be our cheapest resource? Forage only. And then if the forage is not meeting an animal's energy needs, we usually start with energy. Then we're going to add an energy feed, because that's the next cheapest feed. Then we'll check protein. If protein needs aren't met, then we're going to bring in a protein feed, etc., etc. So it's a stepwise progression that we're going to be working through. So what information we need to have for a substitution problem is we got to know our general feed classes. The major feed is almost always forage. You've got to be able to identify, if I give you a list of feeds, which one's the energy feed, the protein source, and the mineral sources. And with practice, you get better at these types of things. And so in the next video, we're going to work through this example of a group of hair sheep in Florida just for fun because I thought I'd pull in some Florida feeds for something different. They got to be fed better. We're going to meet a specific set of needs. So we're going to take the next video and work through a substitution problem.